Okay, so we're going to look at right angle triangle trigonometry. So let's look at the trigonometric ratios, sine, cosine and tangent. Sine theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. Remember that those words opposite and adjacent refer to the side's position in relation to one of the acute angles in the triangle. So for this angle, theta, the side opposite is the side furthest away, and the adjacent side is the side which is closest to theta. It's the side next to theta, and the hypotenuse is opposite the right angle. Okay, so let's look at the first one. So we've got to find sine alpha. So here's alpha just here. Here's the angle alpha. We know the formula is opposite over hypotenuse, which is equal to, let's work it out now. Here's the opposite side, and here's the adjacent side, and here's the hypotenuse. So we just want the opposite side and the hypotenuse, so it's going to be 1 over root 5. There we go, 1 over root 5 there. Okay, now for cosine r, we know cosine is adjacent over hypotenuse. So let's label this. Here's my angle r. So here's my side, which is opposite. This is the hypotenuse, and this is the adjacent side. Now we just want the adjacent and hypotenuse side, so it's going to be 8 over 10, which simplifies to 4/5. Now tan alpha, we know tan is opposite over adjacent. So let's have a look at it. And it's the side opposite to angle A and the side adjacent to angle A. Here's angle A. The side furthest away is the opposite side, and then the side next to it, whoops, on the other side. Side next to it is here. This is the adjacent side, and the side opposite the right angle is the hypotenuse, just there. Okay, so the opposite side is 20. The adjacent side to A is 21, so that's our answer for the first one. Now, for tan B, we're doing opposite over adjacent again, but this time it's the side opposite to angle B and the side adjacent to angle B. Let's rub other labels out. The hypotenuse always stays in the same place, so that's the hypotenuse. Here's angle B. The side opposite angle B is over here, and the side adjacent to angle B is over here. So opposite is 21, adjacent is 20. So that's the answer for those. Now sort of finding a side. So we're going to start off with the same method. We're going to have opposite side here. This is the adjacent side, and this is the hypotenuse. Now you have to choose which trig ratio you're using. Now we're given information on this side, which is the adjacent side. We've got to find W. We're also given information on the hypotenuse. Okay, so we're looking at the adjacent side and the hypotenuse. So if you think about the word SOHCAHTOA, that's going to help us choose which trig ratio to use. Okay, so the adjacent side and the hypotenuse are the two sides we want, so adjacent and hypotenuse. That means we need cosine for this one. So this will be cosine of 35 degrees, 26 minutes, is equal to the adjacent side, which is W, over 15.6. Okay, so 15.6. So multiply both sides by 15.6. That cancels the 15.6 there. And then get your calculator out for the calculation. So let's have a look at that. Where's my calculator gone? Still have to come back here for a minute. And come back here. Okay, so here's my calculator. I'm going to make sure it's in degrees mode. So shift, set up, see where it says degrees, press 3. So now it's in degrees mode. And we're going to put in 15.6 multiplied by cosine of 35 degrees, 26 minutes. equals. Okay, that's 12.71. So our answer will be, to one decimal place, 12.7 meters. And we should use the approximate sign because we're rounding. Okay, now, next one. Here's our angle. Label the sides. That's the opposite side there. This is a hypotenuse now. So think back to our word, SOHCAHTOA. Opposite and hypotenuse is what we're working with. So opposite and hypotenuse must be sine. Okay, so write the formula down. Sine theta is opposite over hypotenuse. And then theta is 67.8 degrees, which equals 12 over k. Now, we have the pronumeral in the denominator. When this happens, we're going to swap the k with sine of 67.8. That's the quickest way for the working out. So k goes there, and that becomes 12 over sine 67.8 degrees, which equals. Okay, so let's get our calculator ready. And it'll be 12 over sine 67.8. And that will give us 12.96, which to one decimal place is 13.0 centimeters. Okay, use the approximation symbol because we're rounding. Okay, we're going to look at finding an angle now, which means we're going to be rounding our answers to the nearest degree or nearest minute. So just a reminder, 1 degree can be broken up into 60 smaller pieces called minutes. And this is how we write it down. 1 degree is 60 minutes. And 1 minute can be broken up into 60 smaller pieces called seconds. So 1 minute is equal to 60 seconds. So if you see something like this, 48 degrees, this reads as 48 degrees, 35 minutes, and 56 seconds. Now, if we're rounding an angle to the nearest degree or minute, we use 30 as the halfway mark. Now, rounding to the nearest degree, put a little line down here. Round up if the minutes are 30 or more. Okay, so if you look at this here, 18 degrees, 30 minutes, 26 seconds. Here the minutes are 30 or more. So this angle here is approximately 19 degrees to the nearest degree. Right, just looking at the 30. So we push the 18 up to the 19. Over here we can see that the minutes are 30 or more. So 25 degrees goes up to 26 degrees. And here we can see that the minutes are lower than 30. So we round down, so this is 32 degrees to the nearest degree. Now, if you're rounding to the nearest minute, you round up if the seconds are 30 or more. Okay, so if you look at the first one, you can see we've got 30 seconds, which means the minutes, which is 15, gets pushed up to 16 minutes. So this angle to the nearest minute will be 84 degrees, 16 minutes. For the next one, to the nearest minute, we look at the seconds again. You see the seconds are 30 or more, so the 15 gets rounded up to 16 again. So that's 84 degrees, 16 minutes. And here, in the last one, you can see that the minutes are less than 30. Sorry, the seconds are less than 30, so the minute of 15 stays as 15. So you get 84 degrees, 15 minutes as your answer to the nearest minute. Now, if the angle is in decimal form, then use the usual rules for rounding. So 10.5 degrees would be approximately 11 degrees, because if it's 0.5 or more, you round up. Here, 36.42 to the nearest degree. If I look at the 4 there, that's not 5 or more, so we round down to 36 degrees to the nearest degree. Okay, let's look at using that now to find an angle to the nearest degree or minute. So here's my theta angle. I'm going to label the sides. This is opposite and this is adjacent. That means we're using the tan ratio. So tan 30 is equal to 35 on 24, because remember this is the opposite side. Right, opposite side divided by the adjacent side. All right, now we need to use the inverse tan function on your calculator, and the inverse tan function looks like this, a little -1. You would have seen that before. Okay, so let's have a look on your calculator what to do. So we're going to go Shift, tan, press the fraction key, 35 over 24, click to the right, close brackets, equals. Now that's 55.56 degrees approximately, so equals 55.56 degrees. Now we need to put this to the nearest degree and the nearest minute. So I'm going to say for theta to be the nearest degree, have a look, 55.56. Now if I look at the 0.5 there, that's 5 or more, so I'm going to push it up to the nearest degree. So to the nearest degree, theta is approximately 56 degrees. Now if we were to round this to the nearest minute, we would need to use our degrees, minutes, seconds button, which is here. So click on that, and you've got 55 degrees, 33 minutes, 39 seconds. Now the seconds are 30 or more, so the 33 will go up to 34. So that means to the nearest minute is 55 degrees, 34 minutes. Okay, so those are the two answers that you have to do, nearest degree and nearest minute. Now, last of all, let's have a look at angles of elevation and depression. So the angle of elevation is the angle between the horizontal and the line of sight when looking up. So here's your line of sight here, if you like. Here's your eyeball, you're looking up. Okay, and here's the horizontal. Okay, so the angle between the horizontal and the line of sight is the angle of elevation. For the angle of depression, you've got to imagine that you're now looking down. So here's your eyeball again. Okay, this is your line of sight. You're looking down at the duck, and the angle between the horizontal and line of sight when looking down is the angle of depression. So here is the angle of depression here, right, marked by theta. All right, and here's the horizontal line. Now, the other thing you've got to know about the angle of depression, that is because this line here, I put double arrows, this line is parallel to this line. Because of that, this angle here in red is also equal to theta, right, because of alternate angles. So this angle here and this angle here are alternate angles on parallel lines, so they're equal. So once you know the angle of depression, you also know the angle down here, the other alternate angle. One other useful thing you can use is if the angle of depression is theta, then this angle in here is 90 minus theta. That's this angle here. Okay, the reason for that is this is a right angle as well, just here. So let's have a look at a question. So it says the angle of elevation from a yacht to the top of a cliff is 18 degrees. So there's your angle of elevation just there. If the yacht is 190 meters from the base of the cliff, find correct 1 decimal place the height of the cliff. Now the height of the cliff, you're going to put H just here. We're going to call this a right angle. And we're going to label the sides. So here is the opposite side, and here is the adjacent side here. That means we're working with tan. We know tan theta is opposite divided by adjacent. So if I now replace theta with 18 degrees, you're going to get tan of 18 degrees is equal to H on 190. Okay, now we're going to multiply both sides by 190. Both sides by 190. Right, that'll cancel 190s, and now we're going to put that into the calculator. Okay, so let's do that. So you've got 190 times tan of 18, which is 61.73. Okay, now to the accuracy of 1 decimal place, that's going to be 61.7 meters. And we should put approximation signs because we're rounding. Okay, now let's look at the next one. Now, here we're given the angle of depression. So the angle of depression of the boat from the top of the cliff is 8 degrees. So here it is. Here's our angle of 8 degrees of depression. If the boat is 350 meters from the base of the cliff, calculate the height of the cliff. Now, they've labeled the diagram for you, so that makes it nice and easy. Now remember, if this is 8 degrees, then we straight away know, and this should be a little horizontal line here. You know straight away that this is also 8 degrees, right? Because this line is parallel to this line, and alternate angles on parallel lines are equal. So we know that's 8 degrees. The next thing is to label the diagram. So this is the opposite side, and this is the adjacent side. So this is tan again. Won't always be tan, but this time it is. So we know tan theta is opposite divided by adjacent. Now, 8 degrees is my angle. So that's 8 degrees. And the opposite side is h, and the adjacent side is 350 now. Okay, so we're going to multiply both sides by 350 times 350, and that gives us, let's have a look, we'll get our calculator out, clear, 350 times tan 8, close bracket, that gives me 49.18 meters. To the nearest meter, that'll be 49. So we'll just write down this is 49 meters approximately to the nearest meter. Okay, and that's it.